Hey everyone, Tom here. So today someone asked me if I could set them a LabVIEW challenge because they've only just started with LabVIEW. Well, they're about core 1 sort of level. And so I said, sure, check out the Sierpinski triangle or the chaos game. So see if you can use your new LabVIEW skills to create a Sierpinski triangle, and I'll put one just here for you in case you didn't know what they were. Then I realised, wait, I've never done it myself. So I'm going to now test myself to see how well I could do it without any real preparation. So I must admit, I did look at a Wikipedia article, which I'll put on screen here. But yeah, let's see how we get on. So I've just created a blank LabVIEW project, and let's just get started. So I must admit, I use a lot of VI shortcuts, LabVIEW shortcuts, so I'll make sure they're all recorded as well. Okay, let's start off by creating a bit of a user interface. I'm going to plot everything on an XY graph. So let's make that nice and big. Plot 0, yep, come back to that. Okay, so the first thing we need for a Sierpinski triangle is, well, 3 random numbers. So I'm going to create myself a random number generator. So there's one already in LabVIEW. Well, that goes 0 to 1. So I'm going to modify that. Now, got a random number generator, multiply that by something. And then round towards negative infinity. So the reason why I round towards negative infinity as opposed to round to nearest is because if you think about it, the two extremities of my random number range only get half the probability. So if I round down, there's an equal probability for everyone, apart from the last one, which gets 0 probability. So I'm going to increment. Oh, cheeky shortcut, Control space, Control D. So we have an input of max value and an output of random number. Cool, let's change this pattern. And make that nice and small. I don't know if it's just a thing that I do, but I like to have my VIs quite small so they don't take up as much screen space. Whether you do that, well, not sure. Put a random number there. Just make those line up a bit and save. Save that as random number generator, close, and back to the block diagram. So I need 3 sets of coordinates. Let's do that in a loop. Random number generator, 1 for x, 1 for y. We'll bundle those together. Sometimes I get frustrated with LabVIEW. It's just this crazy wiring. Wire that up and then create constant 3. If we run this, look on our block front panel. Now we're not seeing anything. Why is that? Ah, I know. Let's change this. Column plots. Okay, so you were getting a plot. It's just, are they all in a row? Ah, no, I didn't enter a max value. Okay, that was a rookie mistake. Okay, that is a hella good reason why when we create sub-VIs, we should always make sure we set this connection is required, and also have a non-default value for your inputs. Native operations, make current value default. Cool, so now we're getting some actual points. Let's look at point style. Make those dark. So there's 1 point here, 1 point right in the corner, and another point right down there. Cool. Awesome, and it's auto scaling, hence why I've always need corners. Right, what do I need to do now? Oh, I suppose I actually need a fourth for my very first random point. So I'm going to create 4 random coordinates, and then do a cheeky bit of array manipulation. Okay, so now create indicator. Can you see what I've done? So this top one here, this is going to be our 3 starting coordinates, and then this deleted portion is going to be the 4th or the 3rd index coordinate for our. Oh, words are hard when you're recording. Right. Right, another trick here, whenever you think you're about to put a constant down, think of y and what that relationship has with others. So I know here I'm going to split this array 1 element before the rest. So if I'm creating 4 random numbers here, I want to have 3 go out to form our triangle, and the last one as our starting point. Awesome. Let's just full screen that. What do I need to do now? Okay, we can actually start on the fun stuff. Let's create a for loop, and this number here is going to be the number of iterations we want to have in our chaos game. So let's create control, number of points. Now this is going to be quite a large number, like maybe 10,000 something. And each one of those points is going to be a new point in our XY graph, which is just a massive array. So actually, I've just thought I'm going to initialize our array, and the dimension size is going to be the number of points. So instead of wiring it there, we're going to auto index, and let us create a constant here. Okay, so one single set of points is an XY pair, like so. This deleted portion isn't actually a deleted portion. We're going to use that as our starting value, and our new value is going to update every single iteration. So let's replace that with a shift register. Replace array subset. Why don't you like that? Oh, it's auto indexing there. Okay. Disable indexing. And okay, yeah, we'll wire that. Cool. So every iteration here, I'm going to start off by replacing the 0th index in our array, then the 1st, 2nd, 3rd, 4th, all the way up to, I guess, 10,000. 10,000's the number I've been using. I mean, I have no idea whether that's correct or not. But well, it was on the internet, so it must be true. Let's replace that with a shift register. Oh, and this XY graph. Oh, we're updating here. So, I mean, for maximum efficiency, I would have this XY graph outside of the for loop, but it'll be quite cool to see all the points appear in real time as the computer's processing it. So I've put it inside. Nice. So the chaos game itself, let's just bring all of this over a bit, make it nice and neat. So the chaos game itself is all about finding the average between your first set of points and your new set of points. So you get halfway in between two data sets. So this is our initial. These are our initial 3 coordinates. So, sorry, I've just realised how this actually works. So the point is that we get our new random coordinate. We then randomly choose whether we aim towards first, second, or third point in our original triangle, and then plot a point halfway between the place we just pointed to and one of those corners. So, I'm glad I created this random number thing here. Because on every iteration, I'm going to pick a corner to head towards. And those corners are in this array. Here, I want our max value to be 2. Let's not have any coercion dots there. Okay, so now I need to find the average between our corner that we have randomly picked. So this here will randomly choose whether it's corner 1, 2, or 3. I am now going to find the average between the corners and our last data point. So if this was our last data point in the shift register, let us unbundle that. And then add them together, multiply by 0.5. So our x's are at the top. Our y's are at the bottom. I will multiply both of these by 0.5. So create constant. I could have also divided by 2. Quick maths. Cheeky bundle. God, I've noticed that I keep calling everything cheeky. There are very few things in LabVIEW are cheeky. Oh, hey. Okay, so we've got a number of points to plot here. Let's see what that gives us. Let's just plot 100 points. That kind of looks like a triangle. Okay, I'm actually going to plot 1,000, 10,000. Okay, I'm going to be brave. Run. Run. Hey! That kind of looks cool. Yeah, now that's definitely a Sierpinski triangle. Now, because I'm doing random coordinates to start with, it's like the triangle isn't just going to be an equilateral triangle. Hence why I'm pressing Ctrl R a couple of times. Oh, now that's really cool. I like that. Ooh, we have these random points like around here. Why is that? It's because we're creating our first random point, which is here on the screen. That isn't necessarily inside a triangle, and then it finds halfway towards a random point, and then halfway towards another random point, and so it might take a few times to get to the triangle itself. I want to actually see that. So plot 0, let's make that the original coordinates boundaries. Let's call that bound. Plot 1, first random point. Ooh. Plot 2, next 1, 2, 3, 4, 5, let's say. And then the rest. Let's customize these. So our initial triangle will be in blue dots, then red dots, the next 5, I guess green dots. Got some RGB going on here, or BRG in this case. Right, start, and the rest, well, if I'm doing 10,000 points, I guess I'm going to have some little black dots. I'll start off with the really small dots and see how we get on. Oh, of course it's not going to update because I haven't actually programmed anything. Alright. Okay, so what did I actually do there? So 1, 2, 3, 4 plots. I never remember how to plot something on a multi-plot graph. Okay, index array, not index array, build array. I'm sure the way you do multi-plot graphs in LabVIEW changes every time I attempt to do it. So this is our initial one. Then from the initial, what else did we have? Oh, it was the first, then next 5. Oh, that's just a cluster, so I actually need to build this into an array. Excuse me, well, let's just get quite pernickety of how we do this. What do I want to do now? It was, okay, next 5 after that. Next 5 values, how am I going to do that? Array subset. Index 0, length of 5. Does anyone else think LabVIEW is strangely addictive? I mean, it's okay if not, it's just me. Hey! That's quite cool. I can't really see that on screen though. So, oh yeah, we've got our corners in blue. Our first point, we should have a red point. Ah, there's the red point. And then some green points. I can't really see those. And then the rest are in black. Nice. Okay, I've got 10,000 points here. I'm going 50. Okay, I haven't put a pause in this for loop, so I'm curious to see what my CPU usage is going to be like. Why is it already at 35%? Right. Nice, we run this. No, it's not great. Also, I have no idea of how long this will take. Okay, that triangle's not very good. It's just so I get an idea of where in the process we are. I'm actually going to put a little progress bar. So that's in numeric, vertical progress. Let's call that progress. Now the progress is going to be current iteration over total iterations multiplied by 100. Create a 64-bit there. Let's just typecast that down to a U8. Save that, Control E. Let's run our code. A little progress bar is working nicely. Oh, so this is cool. So we have our 3 initial corner dots, then a red dot, then our next 5 in green, and the Sierpinski triangle is made up of itself. So to show that, let's put it on the graph palette and just zoom in. So you can see this triangle is made up of 3 other bigger triangles. If I zoom in onto one of those triangles, you see we have the same sort of plot. Let's zoom in again. Same plot again. Our plot, the plot thickens. No, our plot is unthickening. What's the word for unthickening? Let me know in the comments. Oh, that's quite neat. And here we have another one, again random numbers. So our initial point is at 3 and 5. We have a triangle. Nice. Alright, so this was my attempt at the chaos game. Now it's going to drive me mad with all of these unnecessary elbows in my code, but oh, I had fun doing it. Why don't you have a go yourself? Ah, awesome. Alright guys, see you later. Love you lots.